ln. Okay, so I just want to show you guys what your book gives you, and then like it's easier way for you guys to think about it.
One over x. Yeah, we're supposed to have that back. There's that. Oh, yeah, I never did that either. Oh, gosh.
It's not as bad as a book. Your book like makes it very like in depth, but you really only need to know one rule for this. So the derivative of ln x. So say right, the derivative of ln x is 1 over x. But we don't really need to memorize this. What you guys could memorize here is basically every time you're taking u prime over u. So the ln of u, again, your book has this fancy notation that you're doing the derivative of u over u. This is really what you guys want to like memorize, right? It works for both of them because you guys think about this, general form. Your u is going to be whatever that ln is connected to. But if you let x equal u, what's the derivative of that?
1.
Good. So if you have u prime is just 1, so that's why it's like 1 over x, u prime over u. So see how it's like an extra thing for you guys to kind of memorize? But it really is the same thing of doing u prime over u every time. Some things that when you guys are taking your derivatives that we want to make sure you do, right, when differentiating ln, right? Okay, so here's some of your little stuff. You may need to use, oops, let's spell prime correctly. You may need to make like a u substitution. Even though this is kind of a weird concept because you guys have only done u substitution when you're integrating, but we could take that idea of whatever, is with your ln to make that a u, kind of like here, and I'm doing u prime over u. So that's what I mean by like a u substitution. We also are going to see other things come up like your product rule and your quotient rule. I know, from way back. Right. We are going to see maybe chain rule. Okay. And rewriting using ln properties. Yep, it is. It just keeps like rolling it together.
Too late to drop the ball.
No, you're almost done. You're almost done. This is like our last chapter. Right. So we're gonna start off with this like pretty easy, and you guys will see kind of how they can like evolve into like some tougher stuff. So for your first example, we're gonna have f of x equals ln of x minus 1. Okay. So when we look at our function, we have the ln of a quantity. We don't have, an exponent on the outside. There's not too much to rewrite here. So when you guys are using this, we want to think about what's with the ln as being the u, right? So if you have anything like in ln of something, let that something be a u. So I'm going to say let u equal x minus 1. Okay. Then what would the derivative of u or du be? 1. Good. Okay, so now all I need to do is use my property, the ln of u. If I'm taking the derivative of that, it's just going to be u prime over u. So we're going to take, you got it, Kyle. So we're going to take our u prime, which is 1 over x minus 1. That's it. Not too bad. It looks like the notation up here looks crazy when you do it in your book. In the book, this is really what you're doing every time. It's u prime over u. Right? And again, these are general. They do get tougher, but let's try now. So we have f of x equals the ln of 2x squared plus 1. Right. Okay, so now we're going to take the derivative of all these. What do you guys think about your u value? Any ideas? Good. Okay, awesome. So u is equal to 2x squared plus 1. How about du?
4x.
Great. Okay, so at the end, all we're doing is going to put du over u, 4x over 2x squared plus 1. If ever you guys can, reduce something, we want to, right, make sure we're not canceling, parts of sums out. So this is it. Not too bad so far, hopefully. Don't present craziness. Now you could also get things though that are not just like one, using like one property, I should say. So if I was going to take, let's write this a different way, d dx of x squared ln x, right? What this means is taking the derivative of x squared ln x. Just so you guys could see it if it didn't tell you to take the derivative. So here, you guys have your ln of something, but what else is going on with this?
There's an expert.
There's an expert. What rule do you guys think we would need?
Or no, product rule.
Product rule, yeah, product rule. Because you have two things that are being multiplied, right? So here we're going to have to use product rule.
Are you gonna still have a line in it at the end?
Yep. Yep, we will. That's okay. All right. So, your product rule, you guys had, and remember, product rule is commutative with a lot of this stuff. So you could have u v prime plus u prime v, but just remember that they just had to be different, each of them. Okay. All right. So your u, here's your v. So if you guys did uv prime, what's that prime? U is x squared. Good. So we have x squared. Now, if we take the derivative of ln x, Sean? 1 over x. Good job. Good. Plus. Now, u prime, what would that one give you guys? 2x. Good. And the v is just ln x. Good. Right. Oh, never mind. You sure? Yep. ln x, this is like just the general rule. So when you guys see ln x like that, it's coming from, take the derivative, it's just always going to be 1 over x. If that's something you want to know. Or if we don't know it, it's okay to say, if you wanted to actually write it all out and let x equal u, and if you did your du, the derivative that would be 1. Then you could do du over u, 1 over x. So whatever way you want, it doesn't matter. Okay. So when we reduce things, can you guys reduce anything in here?
Yeah.
Yep.
X over 1.
Good, just x. Nice. So this is like x plus 2x ln x. Your book, I think that they like to factor at the end, like factoring out GCF. So if you guys, get something like this and it doesn't match what you get in the back, what's your GCF here? X. Good. So we're going to take out our x, and then we would have 1 plus 2 ln x.
Oh, the x stays.
Yeah, because you can't have ln and nothing.
Oh.
Kind of like, let me think of, it's kind of similar to if you had x squared sine x, something like that.
Oh, it can't just be sine.
Right, yeah, you can't just have sine there. Okay. So you're only taking the GCF from the coefficient. All right. Yeah, so this should be your final answer. You like this stuff?
I don't like it.
No.
Oh,
This is
Actually,
chain, yeah. You could probably do chain here. Or actually, Kara, we have a way to make this easier for ourselves using properties. Otherwise, you would have to use chain.
Yeah, X minus 1.
Yeah. Now, one thing I did notice was when you're taking the derivative of these ln, There's two ways to do it. You can, what you were saying, Sarah, using like a chain rule, or sometimes we can make it easier by using properties and then doing the differentiation. You should get the same thing either way, just one way might be easier. So
it's x plus or minus 2, right?
All right. What? Do you have the answer on it? Tyler, you giving me the answer?
Well, if you take the square root of x squared minus 4, isn't that just x plus minus 2?
No, it's got some kind of, there's some property for it. I can't remember the rule though. It doesn't just like take the square root. Yeah, I'm pretty sure. Do you know what I'm talking about? Did you guys learn it in pre-calc?
I don't mean that you can't do it individually.
Yeah, Google something with the stat. There's some kind of rule. I think there's something in the middle part that it becomes. Maybe a 2BC. I don't know. I can't really remember. But I know you can't do it individually like that. All right, sorry. So, Sarah, I like what you were saying. What did you do to rewrite this? Because I think maybe
put it in the one.
Good job. Yep. So ln x squared minus 4 to the 1/2. Okay. So we have two options here. You guys can you can make this whole thing a u, but you'd have to end up using some kind of a chain rule. Or what we can do to make things easier, and you want to kind of be on the lookout for this when you know you can do it. To rewrite using properties. So if you're going to use your log properties, where does this 1/2 go? In the front. Awesome. Okay. So now we're going to take 1/2 ln x squared minus 4.
Are they going to be zero to the inside?
Yes. Nice. So what you're really going to be doing is just taking the derivative of this part. So if you're just working with this, and at the end we're going to be multiplying by 1/2, what's your u going to be?
X squared minus 4.
Good. X squared minus 4. Awesome. So, Kaylee, what's your du? Or u prime?
2x.
Great. Okay. So our last step now is to kind of rewrite all this stuff. When you are doing your derivative of ln of u, yep, 2x over x squared minus 4. Okay. Now we have to times that though by 1/2. What can we get rid of? 2,000. I'm sorry.
The 1/2 that went to the front.
No, what are you using a rule or are you
Yeah. That's all right.
It's just regular derivative. You don't have to chain rule or anything.
You're gonna have to be doing u prime over u. Sarah, you do that this much in the front, right?
Yeah.
Okay. So now when you have the ln of just like one quantity, nothing else going on with it, you let your u be the bubble part. Right. Then you got to take your derivative of u, which is the derivative of what was in the inside part of that bubble. Okay, so if you took the derivative, just 2x. Right. You're using the property. Yeah, you're using this u prime over u. Every time when you take the ln of just like one quantity, it's always going to be that. Does that make sense? Where like the u prime and u kind of came from? Yeah. Just make sure at the end. You know, if this was your u prime over u, from right here, just don't forget to bring that 1/2 back through. Okay. So at the end, when you guys do all your multiplication and simplifying, it should just be x over x squared minus 4. Good, bad? I don't know. I mean, some of them get a little bit complicated as you're going through. I just want to make sure I show you guys enough variety and like how they could be, like so you could do your homework tonight.
That's what.
If anything was open a window chair too, it's
Yeah,
hot.
it's really
Isn't
hot
it?
in here.
Like, holy cow. Feel free to control this. This is a pretty tough one, I think. All right. Alright, so when you guys look at this one, do you think that we want to let this entire thing be u and try to do the derivative?
No.
No, alright. What can we do to make things easier?
Make t squared plus 3 cubed. Take that u.
And then when you bring t out from
T squared.
Do you have to do
We
the
can't
product
bring t
product
from.
rule?
What are you thinking?
Product rule on the inside? So there's two things that you multiply?
Oh wow, okay. So Kaylee, alright, this is what would go on, alright? Don't write this down, okay? But if you guys let your u equal this, right? Don't write it down though. There's gonna be a way easier way that you guys will like. That's fine. Now your du, if you were gonna take the derivative of that, Kaylee, you'd have to, you're right, you'd have to use product rule, but inside that product rule, what would you have to do here? Chain rule. So this is gonna get like very complicated and very complicated to
product
reduce.
rule and chain rule?
Yeah, but we don't, I mean, I don't know what you guys, you can, I like how you guys thought of that though. You can do it this way, it's not wrong, right? But when you go to reduce, it's gonna be a lot of, a lot of terrible algebra work to do, okay? So when you guys have that, if you notice that something's gonna become very, very complicated and you have a lot going on here, can you apply your log rules and rewrite this?
Yeah.
Yeah, so let's use our log properties to rewrite. Okay. So if I take my ln and I bring it through here, okay, what would you guys have first with your ln(t)? What operation is going on between these? Good, so instead of multiplication, we're going to add, right? Is this 3 belonging with this t or just the inside? Just the inside, good. So now, we kind of kept this going to expand it out. Anybody know what we'd have next?
3 ln t squared.
Perfect, good. 3 ln, and then you guys said t squared plus 3? C. Great. Okay, so now what this turns into is something much, much easier. We're going to be taking the derivative of each little section, right? We're going to, well, here we don't have x's, so it's going to be like d dt, because we're taking the derivative with respect to t's. Kind of weird, but fine. Right. What would you guys make the ln of t?
1.
1 over
T.
t. Good. Because if you, it's kind of like how the ln of x was just 1 over x. We don't still have an x, just 1 over t. All right, now this part, what do you want, do we need to use a product rule? Do we want to make something be u? Any ideas?
Make t squared plus 3u.
Yeah, make sure, good. So t squared plus 3 is going to equal u.
Can you leave the 3 to like multiply through that?
Yeah, at the end, this is a constant, so we're just going to deal with that at the end. What's your du? Awesome, nice, Eamon. Okay, so this confused you guys last time. Make sure when we're taking the ln of u, we're using the property u prime over u. So in here, our u prime is the du. Okay, so we're going to do qt over t squared. There we go, that's 3. Take a look and see if you guys can kind of like, you understand where at least things are going. Is this part okay so far? Okay. Alright, just make sure you clean things up at the end. Alright, multiply these out. So we got 6t, t squared plus 3, and 1 over t. If it's something easy to make the common denominator, I saw in your book they do. If it's not easy, they just kind of left it. Like this one, they just left. Let me give you guys
Matt just tried stabbing Eamon.
What?
Matt just tried stabbing Eamon.
Alright, let me give you guys this one to try.
You know Fridays are away when it's a fundraiser? I don't think I'm gonna ride the bus tomorrow. We're only in Valley, but the boys.
And again, there's more than one way to do this. There's more than one way. You could do Hody Hylio or use your rules, log rules. makes it much, much easier.
Well,
Back
that's
my
just
truck,
two
or my
x
car, I
times
have
one over x
I
plus
have a
3, is
truck.
that what you mean?
Have them all do it. No, it's not.
Oh, minus, right?
Well,
ln of 2x minus ln of x
it'd
plus
be
3.
like, when you do your numbers, well, wait, 2 over 2x. So 1 over x. Should still be your.
No, what I'm saying is, that's 2x times 1 over x plus 3. Would that make it easier? 2x over 1 times 1 over x plus 3. You know what I'm saying or no?
Oh, like
Break it
actually
down.
divide?
Yeah.
No,
How we make it?
you're not putting your bar.
What's 1
Oh, I'm not even trying.
times 26? 2x over
You're
1
talking back to
times 1 over x plus 3. If you break it up
Oh,
like
yeah,
that.
that's the same thing.
Exactly, that's what I'm saying, but you need to take the ln out from separate, don't you? Or do we want to do it anyway?
Well, you're making, see, here's the only thing, you just
Or, you know, it's x plus 3 to the negative 1. So you can put the negative 1 in the front, negative 1 ln x plus 3. So you can do it that way. Right?
Do it out. I feel like you're making it go 2 steps to get the same thing. Why don't you just make it ln 2x minus ln x plus 3? And just apply your logic. You know what I mean?
I didn't think of that.
Oh, really? See, like, I think the reason is how, I'm
2 over, wait, no, I can cross it out.
in addition.
1 over x
You
minus
change
1
it to
over x plus.
multiplication.
Well, that's what
Oh, wait,
it is.
actually, hang on. All right, wait a minute. So what you were thinking about, you know, you x
Like right there, yeah.
3 to the negative 1. Then we take your 3 and we'll have a minus in the middle. You can do it your way. So you do that. It's gonna, you're gonna have to do like an extra like negative, maybe a plus negative tile. Oh, I think I'm talking about here.
Yeah, me too.
So this is good.
ln of 2x minus 3.
Oh, I forgot that.
Oh, I forgot that.
Yeah, it's gonna come down.
I don't know.
Right, you got.
Trust me.
Yes,
Oh, you're
nice.
really
Alright, good, get a common denominator. Now,
I did up here.
we did it?
But after that, you're fine.
Kaylee, perfect. Alright,
So that
thanks.
I gotta
You
find
can
it.
do whatever you want.
It just hit me. So if I just like add it.
What we do is like 10 seconds here, use your rules here, then we will just go on this stuff.
3 over. I thought before he gave me ln for something, it was always 1 over.
It's like it's just one thing. Yeah, it's
I think
one
my mom
over
gave
something.
your
But
mom
this
ours,
wasn't
but
supposed to
I
be
don't remember.
so that's your view. There's your thing with that. Okay, so that's like 3 over 2x.
So I got it.
Yeah, and then.
I only got it from 9 people.
You're gonna
I
want
wrote
to
down
down
5.
They get 5 times like equal like that.
You problem?
Oh, no, it's gonna be 3 over x squared plus 3 to make sure I have it.
Want to put it up there? Yeah. Yay, good.
Oh gosh,
Okay.
it might be really messy.
Times your denominator.
Oh, okay, this is 35.
Yeah, why is that? They said we should be 39, 40, 41, 42, 43, 44.
So I mean,
I got 5
and you want to
so they have
like,
30
down there.
5, 10, 15, 26, 33, 44.
That's what it is.
Who?
You did $5?
You did?
Maybe that.
You gave me 10?
There is
Because I couldn't figure out, because I had like,
Oh, Kaylee.
5 discrepancy.
I have 5.
okay. You want me to please give it to me in the book? Whenever, tomorrow, what? Today on the book? Because I'm gonna go to my office.
Gotcha.
10.
Something like this is really hard.
You don't have to put 5 on it. Fit 3.
Yeah, good.
I'm sorry.
Brandon gave, or Brent gave you money.
Yeah, Brandon said he was gonna send us when I wasn't there, but I think that he forgot by the time he got there, so it's okay. My mom can just take this with me.
This is good for the rest of the life.
Oh, got it.
Great, okay. Ooh, now.
Carol. He didn't go to your house after school.
Okay, have fun on that. Just be quiet, it's my dad's
No, it's already like soft. What's like multiply by something or not?
I'm sorry.
320.
Think she's what she's bringing?
Yeah, that's fine.
These two cancel out. I thought you meant this one.
Oh,
This one.
no.
Okay. Yes, I am like. There's no more parentheses anymore.
Actually, awesome.
X plus 3 minus X.
Right.
Heard it. Yep.
Good job, guys. I have some other ones that are a little bit tougher for you guys. So I'm just going to score your homework real quick because I didn't get to do any of the double LNs, which is fine.
Like Ellen of Ellen.
Yeah,
That happens.
that happens.
No, that's.
Well, isn't ln of ln 1 over ln?
You won't be able to finish it in time. So let's do order of homework. 331.
And over Ellen. Over Ellen.
Like 47 57. Right, 47 to 57. Yeah, that's probably fine. Alright, I have that part.